worksheet 1, that will be confident interval for one population, confident interval for two population, hypothesis testing for one population, and hypothesis testing for two population. Now, at the beginning of the worksheet, which will, for example, in this part, I divide it into several sections divided by this particular line, black line, which will tell you that will be the boundary for each discussion. Now, what did I provide you? Some of them are, the first one is the function, Excel function on how to find the critical value, and arrange them into ZCV. For example, if you are using your Z distribution, if you have two tail, then this will be the function needed for you. And this is described by this particular figure, where the critical value involves two sides. As for ZCV left tail, this will be the function, and we are looking for the critical value, that is the value along the X line here, the X axis. The same goes to Z right tail. The critical value is along the X axis, but in this particular value. And definitely when you are talking about critical value, it will be based on the alpha value given to you. For example, if you are talking right tail or left tail, you are using the alpha only. If you are talking about two tail test, then the alpha should be divided into 2 and it will reflect two-sided. Okay. And if you are looking for the t distribution, and by now we should know, if you are using the t distribution, the only reason why we use the t distribution is because the sample size is less than 30. Then you have this particular, definitely just the same as what you have in Z distribution, but it will be using different Excel function because we are referring to t distribution. For two-tail t distribution, this will be the function, and it should you should give the alpha value and the degree of freedom. And the degree of freedom for t will be based on cases where you have. And as I mentioned earlier on, I forgot to share one more. That will be this one, formula sheet. Okay, so please print out your own formula sheet. Okay, this will be a very helpful formula sheet for you to guide you on understanding the problem given, and you can use this during your assessment. Okay, so you can bring that particular formula sheet with you during the assessment. Now, everything has been provided in such a way that you can see if you are talking about the confident interval for the proportion, the confident interval for the mean, where the cases of the sigma is known, sigma is unknown if the n is less or greater than 30, and followed by the sample size for finding the n given the margin of error whatsoever. And you have also hypothesis testing for single population, confident interval for two population, and followed by some of the hypothesis for two population, as well as the ANOVA. This will be on for the chapter 4. This one also for chapter 4. This one is for non-parametric tests, is for chapter 3 and 4, because a non-parametric will involve one population, two population, and more than two population, 3 and above number of population. And finally, for chapter 5, this will be provided. So I really hope you can, print out and not to say study, but look at the the formula on how you can manipulate or use them in helping you out with your problem later. Okay. Anybody who got any question for the formula sheet, class? Any question so far?
No,
Saya
madam.
pun formula yang
Yes. What was that? What was that? The girls just now. What was the question?
final pun formula
This.
yang ni.
Yes. During the final, we will give you this formula sheet will be attached along with your question. So don't worry. For the final exam, we will provide along with the question during the final exam, so you don't have to worry. So it will be helpful for you throughout the learning for chapter 4 and chapter 5, where you can use them as a guideline. Okay, so if you don't have any questions, let me continue again. This one is for additional information. So I have put all the additional information that you should know for confidence interval for two population. And as usual, if you are dealing with statistical inference for mean, the condition for the sigma, for the n, will be taking into account in your problem solving. As usual for mean only, but for proportion, everything will be straightforward. So the same, I provided the Excel function for your reference in every worksheet. Okay. And for hypothesis testing also, I provided the same critical value and finding the p-value for the Z and T distribution. And then in addition to hypothesis testing, this is the one that I have mentioned last time during the class, where I didn't found in the class, but it is actually there. This is on page 108. So this will be a good guideline for you on how to make a decision for hypothesis testing. Last time I did mention, and I believe some of you may have some confusion, where I said you can have your claim either at the null or at the alternative. So what if the claim is at the null and you reject the null statement? Okay, what if the claim is at the alternative statement and you reject the null statement? What would be the conclusion for you to make? So this will be the guideline for you, and I'm not going to discuss further because it would be going to be more confused. It would be good if we just look at the example that we discuss afterward. Okay, so I would like to go again to the confidence interval for two population. Okay, but I would like to highlight for confidence interval for two population, if sigma, because we are dealing with two population, the consideration will be based on the distribution of your sample 1 and sample 2. And if your sigma 1 and sigma 2 means that the distribution is known, the sigma is known, the value of your standard deviation for both populations or for both sample are known. So this will be the only formula that you will use. But if sigma 1 and sigma 2, the standard deviation of your population is unknown, and your reference would always based on the sample standard deviation or variance standard deviation. That's why everything is based on S here. Okay, S, everything S. But here, everything is sigma. So that's why there will be a difference between sigma known and sigma is unknown. Then for sigma unknown, there will be consideration where the n is less than 30, the n is greater than 30. And remember, when you have this formula during your assessment, means that maybe the critical value will be given if, let's say, you don't have any source to refer to your Excel or to refer to your table. That means the value will be provided to you. But we are not going to provide you the calculation. For example, square root of sigma 1 squared over n1 plus s1 s2 squared over n2. This will not be provided. We provide the standard deviation value and the sample size. So it means that the calculation will go back to you. Okay, the same goes here. And why do we have SP here? SP here means standard, that will be standard deviation pool. Okay, pool for this particular population 1 or sample 1 and sample 2. That's why the calculation is based on the the variance and the sample size for both population. And if your n is less than 30, we are going to use the t distribution. Now, there will be a difference between sigma 1 and sigma 2 is not equal. So I'm really sorry. This one should be equal to, but I don't have my pen. My pen is not functioning. So my pen is not functioning, yeah. So please make sure that this one, the one I show you just now, is equal to. We are following the textbook. This is equal to, but this one is not equal to. So the difference is that for the degree of freedom where the sigma 1 and sigma 2 is not equal, then we choose the minimum sample size from the two value. But for sigma 1 and sigma 2 is equal, we are going to add the sample size value. You can see here n1 plus n2 minus 2. And the calculation for the S pool is based on this one. SP, this particular SP, okay, is obtained by using this one. Then the value of this one is multiplied by this square root 1 over n1 plus 1 over n2. So please make sure you understand on how to use this particular formula for your calculation. Okay, so that would be for uh, two population for statistical inference. Now, I would like to know, do you want me to repeat again the confidence interval for two mean difference class? Do you want me to repeat this again? Because I have already put everything for you. We have discussed this actually in class. We also discussed this in class, but if I'm not mistaken, we only did one question only for unknown sigma and equal variance. But for unequal variance, I add again here just for you to double check. Do you want me to repeat again on the confidence interval class for the mean? Can you give your feedback, class? Hello?
Yes, madam.
Yes. Okay. Yes, I hope I can, my phase of explaining will be suitable for you to understand. Okay, let us move to example 3.9. That will be on page 110. Okay. Now, what was the question? Two machines are used to fill plastic bottle with liquid laundry detergent. The standard deviation of fill volume are known to be sigma 1 0.05 and sigma 2 is 0.025 milliliter for two machines respectively. Now, from the first sentence, there will be two things that you have to know. First, the sigma 1 and sigma 2 are given. That will be a hint for you to know that sigma is known in this case. Okay, sigma is unknowns. And what else? Two random sample of bottle from machine 1. Okay, population 1 is based on machine 1 and population 2 is machine 2. Okay, so you can uh, uh, update your Excel because I put population 1 and population 2, or you can just remain population 1 and population 2. Now from machine 1, the sample size is 14. From machine 2, the sample size is 12. And from machine 1, the mean is 30.5 milliliter. And for machine 2 is 29.4 milliliter. And the given standard deviation for machine 1 is 0.005 and machine 2 is 0.025. So what are the things that that you have to understand? First, the point estimate. Okay, the point estimate for the difference between the mean of machine 1 and machine 2 is given by the subtraction of these two values. Okay, and that will be given by this. Mean difference is given by subtraction of 30.5 and 29.4, which give you 1.1. Okay, now that will be the point estimate for the difference between the two population means. Now, what else? Known sigma, and then look for the situation where the n is less than 30. So when n less than 30, so you have this particular situation. Less than 30 is either these two. Now, what else? The information given. Okay. Construct and interpret a 90% confident interval for the difference in the mean fill volume between the two bottles. So we have input our values inside the table. Now we will start finding the critical value, because in finding the confident interval, we have to find the mean difference obtained already. Second, the critical value, in this case, known sigma. Okay, in the case of known sigma, this will be the case. Okay, not looking at the sigma 1 and sigma 2 are not equal, because the known sigma is based on this one. Pardon me for the previous reference for this one just now. So we are using this particular formula for our calculation. Now, for the confident interval, we need the first, the critical value. Okay, the given question is finding the 90% CI. So based on 90%, the significant level or the alpha value is 0.1. So to find the critical value, we have two sides, left and right. So what do we have? We are using the norm.s.inverse 1 minus the significant value divided by 2, because it is a two-tailed test. Okay, and using the Excel function, the critical value is plus minus 1.6449. You can add, if you want to add, that will be the plus minus symbol so that you can remember. Okay, so you add here. Okay, then what else? Then you can continue with your finding the standard error. Now, in order for you to find the margin of error, okay, remember how we get the margin of error? The margin of error, okay, is given by the multiplication of the critical value, that will be Z alpha over 2, with the standard error. So we have to find the standard error. The critical value already obtained here. So the standard error is calculated using this. Okay, and I simplified here. This is the formula. And if I put into the Excel function, this will be the formula. And if you calculate it right, so you will get 0.0073. Okay, so we have got our critical value. We have to multiply with the standard error, which will give you the margin of error. So I just multiply the critical value and the standard error, which will give me the margin of error of 0.0121. Now we can continue with finding the lower confidence limit and the upper confidence limit. So for the lower confidence limit, we will use the mean difference between population 1 and population 2, or machine 1 minus machine 2. Okay, how I find here? I use the mean difference minus the margin of error to find the lower confidence limit. Then I get 1.09. For the upper confidence limit, it will be the mean difference plus the margin of error, and I'll get 1.11. So my final answer can be written as, this one is actually mu1 minus mu2. So please add to your Excel so that you won't get confused. Control C and then Control V, change mu1 minus mu2. So please, I forgot to replace that with the difference between the two population mean. So this is how you can write with your final answer. Okay, so the mean difference is between 1.09 and 1.11. So how can you conclude? So we are 90% confident that the mean difference in fill volume is in the interval of 1.09 ml and 1.11 ml. So that would be your conclusion for your confidence interval. Okay. Any question from this particular example, class? Any question? So if you are using your Excel, I would advise you to be more careful on using your Excel function where you have this not really a hard formula, but in terms of writing it right in the Excel is really crucial for you to make sure that you are giving the correct instruction to your Excel and to find the correct answer. Okay, so I believe you don't have any questions, and let us continue with exercise 3.6. I think this is a good example because in this particular question, we are using T distribution, and this will be a good example where we can see the difference between the T and the Z distribution that we have just did just now. Now, this question is on page 110. Now, the given situation, 17 male and 20 female undergraduate students are randomly selected from Faculty of Mechanical Engineering. The summary of Test 2 EQT 271 results are as follows. So you have the male result, the average result is 82 with a standard deviation of 8, and for the female is 76 for the average value, and standard deviation is 6. Okay, now what else given? Assume that both population are normally distributed, means that you know that you are using the parametric method, and the population variances are equal. So this is the first condition. The first condition means that you are assuming that the sigma 1 and sigma 2 are equal. Construct a 95% confidence interval for the difference in the mean score between all male and female students who took the test. And then assume the population variances are not equal, construct 95%. So you have two questions here. So let us address them one by one. Now put everything, the information given. So we have the male, the sample size is 17, the mean is 82, the standard deviation is 8. So in this case, the standard deviation is referring to your S. Okay, so means that you are having an unknown sigma. And for the female, as given in the information, now let us continue with the finding the confidence interval, which you will have to find the critical value and the margin of error. Now, what is the point estimate for this particular question? Mu1 minus mu2. So mean 1 minus mean 2, which will give you 6. Okay, so you minus the two value, you get 6. Now, the first is finding the critical value. Since the n is less than 30, these two value are less than 30, means that you are going to use your T distribution. So if you are referring to this particular formula, unknown sigma 1 and sigma 2, and n is less than 30, the first the first question, assuming population variances are equal. So equal is over here. As I mentioned, this should be sigma 1 equal to sigma 2. There is a typo here. Yeah? So means that we are using this particular formula. Let us continue. First, find the critical value. Since we are using we are finding the critical value for both sides. So means that we are using this particular information Excel function, where for T distribution, we are going to use directly T inverse dot T 2T. 2T means here is 2 tail. And the input is the alpha value, and the second input is N1 plus N2 minus 2. So if you go to the formula just now, this one, the formula is based the V or the degree of freedoms, because the T will give the critical value is based on T alpha over 2, comma V, where the V is given by N1 plus N2 minus 2. So that's why here I use the instruction here. This I55 is referring to the sigma, or sorry, the alpha, and I49 plus J49 is this particular N1 plus N2 minus 2. So this will give me the critical value. So here again, it should be plus minus. So I'll just copy, okay, plus minus and put it over here. Okay, now what else should I need? I need the standard error. So the standard error again is obtained by S pool multiply with square root of 1 over N1 plus 1 over N2, where S pool is given by this formula. So since the multiplication or the formula is a bit not to say it's a bit too long, so I divided the calculation into several parts. Okay, so this will be for the first part, second part, and then this is the last part. So I find it one by one. Okay, I use the calculation for S pool, and the last one is this one. So I think you can check on your own. So the standard error, I'll just use this, all the sub multiplication of the formula, and to make sure everything correct. So that's why I put it this way. And if I look to the answer, it will be a good correct answer for the standard error. And for the margin of error is the multiplication of the critical value with the standard error, which will give me, okay, which give me 4.6783. So we are going to use these two values to find the lower confidence limit and upper confidence limit. So in this case, okay, for lower confidence limit, 6 minus the margin of error, that's why I get 1.32. And for the upper confidence limit, mean difference plus the margin of error, which give me 10.68. And I can write my final answer as mu1 minus mu2 is between 1.32 and 10.68. This will be the answer for unknown sigma with equal variance. Okay, now the second question is for unequal variance, where the formula for your margin of error will be a bit different, much simpler actually. Okay, much simpler. And for the degree of freedom, it will be based on the smallest between the two, N1 and N2 minus 1. Okay, so that's why in this case, for the unequal variances, okay, for the unequal variances, how I get my critical value, if you look here, I choose the male sample value because the male is minimum or less than the female sample value. That's why in this case, I use the two tail with the sigma, this particular location, I76, and n minus 1, 17 minus 1, and I get 2.1199. So this is my critical value. And for the standard error, using the formula, okay, I simplified my formulation, okay, and I get the margin of error is the multiplication of these two values, TCV and the standard error, which give me 5.0008. And I can continue with my finding the confidence interval for the difference between the two mean of male and female. For the second CI, okay, using the same 95%. So what happened if you are using the T? You can compare the what we call the range between the CI will be a bit smaller for T distribution. So this is my final answer for the confidence interval for unequal variances. Class, any question for this second example or exercise? Any question, class? So in this class, I think you will be there will be a lot on hearing part compared to question and answer, because I have already prepared everything in order. So if, I believe you don't have any questions. Let us move to the um, confidence interval for proportion difference. Now, for proportion difference, it will be straightforward. Okay, it will be straightforward. Unluckily, I did not put the for the proportion, but if I'm using my this particular slide, okay, for the proportion, it will be just a multiplication, always using the Z distribution for the critical value. Because why? Usually for proportion, sample size involved for proportion are always greater than 30. That's why most of the time you are using the Z critical value. And for the margin of error, I mean for the standard error, will be using the multiplication of uh, P hat and Q hat from your given scenario. And again, you have to know how to find the P1 hat, P2 hat. The same goes to the rest of the calculation. Let us move to our Excel. For two population, confidence interval for proportion. Now, based on the example 3.11 on page 111, okay, two separate surveys were carried out to investigate whether or not users of plus highway were in favor of raising the speed limit on highways. Okay, of 250 cars driver interviewed. So you have the first population is for the car driver. Okay, 222 out of 250. So N is 250, X is 220, given in the second sentence. While 200 motorists, so the second population is for the motorists, and out of 200, N is 200, N2 is 200, 180 were in favor of raising the speed limit. So 180 wish or favor raising the speed limit. So this will be the information for the two, car and motorist. Now, finding the P hat for car and motor. Okay, so finding the P hat for car will be definitely X divided by N. Okay, so which will give you 0.88, and the Q hat will be 1 minus the P hat, which will give you 0.12. The same goes to motorists. Okay, and what will be the point estimate for the difference of the two proportion? The point estimate would be this one, proportion difference, that will be P1 minus P2, and it is negative 0.02. So as I mentioned earlier, when you have negative value, it is an illustration for you to know that the value or the proportion value for population 1 is smaller than the proportion of population 2. So that reflect the negative value. Okay, so don't worry too much on the negative. It's just a representation of the sample size of the two population involved in your inference. Now, the critical value. Now, for this particular question, you have to find the 95% confidence interval in the proportion between the car driver and motorist. Means that you have to deduct the car towards the motorist. So that's why it becomes negative. Okay, 0.88 minus 0.9 will give you 0.02. Now the critical value, because you are using the Z, okay, so using the norm dot S inverse 1 minus the alpha, that will be 0.95 divided by 2 will give you the critical value for left and right. Okay, so that will be plus minus 1.96. Now for the standard error, okay, for the standard error, we are using the formula just now. So I'm not going to refer back to the slide. So somewhat I prepared to simplify the calculation. I divided into two. So this will be for population 1 and this one is for population 2. So the calculation for the standard error is just the square root of these two, just following the same exact formula from the textbook. Okay, then I get the margin of error by multiplying the critical value with the standard error, and I get margin of error is 0.0579. Okay, now we can continue with finding the lower confidence limit, which will be the proportion difference minus the margin of error, which give me negative 0.078. But for the upper confidence limit, it will be the addition of the point estimate with the margin of error, and I will get 0.038. And you can write down the answer as this one, minus 0.078 for the difference between proportion 1 and proportion 2, or car against the motorist. Between for the upper limit is 0.038, or if you need to conclude, you can conclude we are 95% confident that the proportion difference between the car and motorist driver are favor of raising the speed limits lies between negative 0. Is actually no negative here because it is a percentage. So 7.8% and 3.8%. Okay, so if you don't want to use the percentage also can, is between negative 0. To be safer lah. Okay, is between negative 0.8 and 0.08. Sorry, it will be negative 0.078 and 0.038. Okay, so you can do it this way also. Okay, now do you want me to go through the exercise class? I think it will be straightforward for the exercise because it is just a simpler one. Is it okay if I just leave this one, class?
Okay, madam.
Okay, yeah. Any question for the proportion? Okay, so during the assessment, I think you don't have to worry. This value, okay, let me put it this way. If I put into a yellow form, most probably you will be given, for example, this value, all this value will be given. Okay. What else? Critical value, yeah, this will be given. So means that P hat, Q hat, for population 1, population 2, everything you have to calculate. Then you can imagine if the yellow part only given means that the rest of the information, for example, the standard error, okay, once you have got your P hat, Q hat, you can calculate the standard error because the standard error is based on this particular formula, right? So this one is just applying the formula where you can refer back to your this particular formula sheet. Different between two population, between two sample proportion. For the confidence interval, yeah, this one. Okay. And for the difference between two population, you can refer to this one. Look at my hand, yeah, my moving hand here. For two population and for one population, Okay, so that would be for confidence interval for proportion difference. For hypothesis testing, one population. Do you want me to repeat, class? Do you want me to repeat one population? No, don't need, okay. So you can refer back. Again, I have put in a form where you will be given this form. So I believe this one will be provided, but let me put it into yellow. Let's say you are being given this one. The question is this one, you are being given this one. What else that you need to know and remember is the procedure of performing the hypothesis testing. As we know that we have 5 steps, right? So the Z test will be given, the p-value will be given, the critical value for the two-tail is given. Now, this form can be given this way. So the question can be left tail, right tail, or two tail. So you have to know which of the values that reflect your requirement. So don't simply, if the question is given for one tail and you use the two tail critical value, then it will be a the end for you. So please make sure that you know which one to use during your problem solving now. Okay, so for the hypothesis testing, I wish you can go back and put it on your own interest on how to understand the given information. So I believe you can see when we provide all this information, your process of finding the conclusion, okay, will have with simpler version where you have to put down your claim or your null and alternative statement and decide which one is the claim that you need to test. Okay, and the decision can be made based on the traditional method or the p-value method or the confidence interval method. So one thing that I did not mention quite a lot during the class is that for hypothesis testing, confidence interval method only applies if the question is for two-tail test. Okay, so for one-tail test, confidence interval cannot be used into making conclusion about your hypothesis testing. So in this particular example, 3.9, we can't use the confidence interval to make a conclusion about your hypothesis testing. But for this particular case, you can use the confidence interval method. As I mentioned here, I did already write something here, so you can check, okay, how you can use the confidence interval method in making conclusion about the hypothesis testing. So I really hope you can look it at your own. Yeah. Now the last part that I think we have to cover before we finish our chapter 3, that will be on Tuesday next week. I will finish the chapter 3 with the non-parametric methods. Okay, so we have two methods under that will be on sign test for one population and Kruskal-Wallis test for two population. Okay, sorry, Mann-Whitney test. So there will be two tests for the hypothesis testing where we have the non-parametric case. Okay. Do you want me to stop for a while or can we continue straight away, class?
Continue.
Continue,
Continue.
Okay. Did my slide clearly portray on your slide, class? Is it clear? Do you want me to enlarge a bit or is it okay this way?
Okay.
Huh?
Dah okey dah.
Okay dah, Okay. Now, as I mentioned, you can recheck again how we can find finding the critical value, finding the p-value. Now remember, the p-value reflect the shaded area. The critical value reflect the value at the x-axis here. These are all critical value. The p-value are based or bounded by the test statistic. That's why I put it here in red, bold, the Z test or the T test. Okay, so the Z test, if you are using the Z, the T test if you're using the T distribution. It will be goes back to the requirement of your problem solving. So the p-value reflect the value bounded by the test statistic. So I really hope that you can capture when I said the test statistic, the t-test, the z-test, the z-statistic, it reflect the test statistic, which is area, the value along the x-axis. Likewise, the critical value just now. But that one is based on the test statistic. Okay, I mentioned quite a lot before. I really hope that you don't confuse with that. Now, okay, for hypothesis testing again, okay, if for the mean, you will have to look at the situation where the known sigma, the unknown sigma, and less than 30 and greater than 30 for the two cases of what you have in the given problem. Now, let us move to first example. Okay, the first example is on page 113, okay, which says the mean lifetime of 30 bulbs produced by company A is 48 hours and the mean lifetime for 35 bulbs produced by company B is 50 hours. So you have the mean for company A is 48, the mean for company B is 50, the N is 30 for A, 35 for B. Now, if the standard deviation of all bulb produced by company A is 3 hours, 3 hours for company A, and standard deviation of all bulb produced by company B is 3.5. Now, look at the statement. Yeah, look at the statement here. Let me put in the line because my pen is not working. So, let me underline the words. If the standard deviation of all bulb, okay, all bulb produced by company A, okay, let me increase the, and let me change the color into red. So you have the first, all of all bulb, second is for B, okay, again the same for B. So means that this is a hint for you, or if I can say, all bulbs means that it is from the population. Okay, the same goes here, it is from the population. That's why in this case, sigma is known. Okay, sigma 1 and sigma 2 is known. And it is clear for you that you can use which what we call, which formula respectively. Okay, now, test at 1% significant level that the mean lifetime of bulb produced by company A is less than company B. Now, in this case, the difference of the two population mean is not given. So how do we understand that? Okay, so if let me go back to my, where I can use my pen. Plastic boundary, mean lifetime. Okay, now this particular what we call situation, now you have this particular claim, test at 1% significant level that the mean lifetime of bulb produced by company A less than company B. We know that, okay, our null statement will always, my mu1 is equal to mu2. This is one way to write it. Or you can write as H null mu1 minus mu2 is equal to 0. It's just the same. Okay. Now, if let's say in this case, it says that the mean lifetime of bulb produced by company A is less than company B. Okay. If we write it that way, how it can be? So null, the third one, the alternative can be mu1 not equal to mu2, or alternative can be mu1 greater than mu2, or mu1 is H1 is mu1 less than mu2. Right? It's all the same. If the null statement is this one, the alternative can be either this one or this one or this one, right? Okay, so in this case, we can write this down as the null mu1 is equal to mu2, and the alternative is mu1 is less than mu2. Mu1 or mu2, or you can say null is mu A equal to mu B, alternative mu A is less than mu B, also can, as long as you know what does the this particular value refers to. Okay, that's why if we go back to the Excel, okay, I wrote it this way: mu1 minus mu2 equal to 0, or mu1 minus mu2 less than 0. It's just the same as writing it down, okay, using this particular sign. Okay, so if this is the case, you can write it as mu h1 equal to mu1 minus mu2 not equal to 0. H1 mu1 minus mu2 greater than 0. H1 mu1 minus mu2 less than 0. So if I put it, this one is the same, okay, this one is the same, and this one is the same. So you can write either this part or this part. Okay, class? At this point, do you have any question, class, on how to come up with your, what we call the notation of your statement to be tested? Any question, class, here? Anybody who's still confused or don't understand? Anybody, class? Are all okay? Class, are you all okay? Any question? Any question, class?
Ada.
No. Okay. Hold on. Now, let's continue. So, we go back to our Excel just now. That's why in this case, okay, I put the information accordingly. Then, why I put hypothesized value is 0, and I wrote this way so that you can easily understand. Okay, sometimes hypothesized mean difference is your mu naught, the mu naught. If you look back at your textbook, okay, this one is you can put it as your mu1 minus mu2. Let me see. Okay, this one is the mu1 minus mu2. Okay, when we say the hypothesized mean, yeah, mu1 minus mu2. Now, in this case, the tested value is 0. Okay, which reflect when less than 0, okay, means that mu1 is smaller than mu2. That's how we reflect from this particular last sentence. Okay, now how to find the left tail test? Because this is less than 0, means this is a left tail test. So left tail test for alpha 0.01. Okay, then the z test is referring to your formula here. For known sigma, z test is calculation using this formula. This is the z test formula, and this is how I found using this particular formula. Okay, and if I look back to my formula, all the given information reflect the given formula are used in the calculation. So if I can go back to my X here just now, okay, this would be let me go. So because this is a known sigma, so definitely this is the first step. The second step would be finding the z-test or finding the critical value. So let's say we are using the finding the z-test first. So the z-test is x bar 1 minus x bar 2 minus the hypothesized value, that is mu1 minus mu2, divided by square root of sigma 1 divided by n1. This one is plus sigma 2 divided by n2. Okay, so this one is equal to what was the value just now? 48 and 50. Okay, the mean difference for 48. So it would be 48 minus 50. The mean lifetime of the A48 is 50. Okay, and this one is equal to 0. So this one is according to the given situation. So if we put everything accordingly, okay, go back to our Excel. So this will be the formula given, and then we use this formula and find the z-test. So the z-test, okay, is where you're bounded for your p-value afterwards. So the p-value is 0.0066. How do I find this? Okay, let me draw again for you, because the p-value is the given probability value under the curve. So from the z-test, the value obtained is negative 2.481. If I draw, okay, so this is mu is equal to 0. And for negative 2.481, okay, so negative 2.481, this is the p-value bounded by the z-test. Or sometimes we call it as test statistic. So don't get confused. These two are the same. Okay, these two are the same. Okay, now what is the critical value? Okay, the critical value for this particular case, this is a left tail test. The critical value using the formula, Excel formula for norm dot inverse based on the left tail test based on 0.01 is negative 2.3263. Okay, so in this case, okay, negative 2.3263. So negative 2 is much smaller. So number 3, number 3 is your critical value, where your Z is 0.01, which give you negative 2.3263, and the value is over here. Let's say lah, is somewhere over here. And this is your Z alpha, Z 0.01, which is negative 2.3263. And these are all the, until here, these are all from this to this area are all alpha. Okay, and if I put it in red, maybe it's much. Okay, so this area in red shaded area are the p value. Okay, this red area, oh, not good. Let me change. Let me take the green one. This one is p-value bounded by the z-test or test statistic. So that's why I put in this particular Excel, okay, I put it this way. So let me increase a bit. Okay, that's why I put it this way. So means that imagine you will be given this information. All these are given in your assessment later. So what you have to think, the rest is how to perform your hypothesis testing and use the information given to carry out the test. Okay, so you should begin with the statement of your null and alternative and jot down which one is the claim. Since this is the last sentence that you need to test, so this will be the claim. And if you use your traditional method, okay, you can see that the test statistic is inside the rejection region. Again, remember rejection region and non-rejection region. So in this case, since the test statistic is smaller than the Z alpha, okay, so we reject the null hypothesis. So if that is the case, reject the null hypothesis. Again, claim is at the alternative and you reject the null. Okay, if yes, there is sufficient evidence to support the claim. So that's why in this case, okay, the conclusion says there is sufficient evidence to support the claim that the mean lifetime of bulb produced by company A is shorter than company B at 1% significant level. So if that is using the traditional method. If you are using your p-value method, okay, since you have understood this particular case, this is your p-value compared to your alpha. If your p-value is smaller than your alpha, it will be reject the null. So that's why in this case, if you are using your p-value method, okay, since p-value is 0.0066 is less than 0.01, then we reject the null hypothesis. Okay, but for confident interval method, we can't do because it is a one-tail test. It's not fulfilling for confident interval method. Okay, any questions so far, class, for these questions? Is it clear, class?
Clear, madam.
Okay, thank you. It gives me a big relief. Huh? Okay. Do you want me to continue with the second example? This one is a right tail test. I think it's just the same. For two tail test, do we have two tail tests over here? We don't have the two tail test. The two tail test is only at the one population, but it's just the same. If I think I want you to try find one question which reflect two tail test for two population, because in the example I did not manage to put for the two tail test. So I really hope you can try on your own, and maybe before our assessment begin on Tuesday, we can have a discussion for a while. If you have still any got problem with some of the question related to two population for hypothesis testing. Now, for the second question, do you want me to explain, or you want to do it on your own? Class, do you want me to continue with the second exercise or straight away to the proportion? Class? Exercise 3.8. Do you want me to discuss or no?
No.
No, okay. We go to the second example. Reflect the inference for the difference in two population proportion. Okay. Now, what is the situation? A researcher wanted to estimate the difference between the percentages of two skincare users who will never switch to another skincare. In a sample of 500 users of skincare A taken by the researcher, 100 said that they will never switch to another skincare. In another sample of 400 user of skincare B taken by the same researcher, 68 said that they will never switch to another skincare. Okay, so if we plot everything into the information structure, we have skincare A, we have skincare B. Okay, now we have the N, we have the X, so we can find the proportion. So basically, you will be given this, okay, in your situation, and you can be given this one. This one also provided. Okay, means that the rest will be the things that you have to discover on your own. So the P hat, the Q hat, the P hat overall, and the Q hat overall. So what are they? Let us see one by one. Okay, let us finish with the question first. At 1% significant level, can we conclude that the proportion of skincare A users who will never switch to another skincare is higher than the proportion of skincare B users? Okay, so definitely if you translate them into the null and alternative statement, you are talking about the proportion 1 and proportion 2, which reflect skincare A and skincare B. Now, class, I want you to really look at the symbol or uh, the notation used in the null and alternative statement. Okay, for example, this one is P1 minus P2. Okay, for proportion. For mean is mu1 minus mu2. Okay, the same goes to CI. Okay, the point estimate is based on the given information. Now, what is the thing that you have to make sure you understand? Why don't we put this way? Why don't we test this way? Why don't we put this way? Null is x bar 1 minus x bar 2, or alternative is equal to 0, x bar 1 minus x bar 2 equal to 0. Or if you are talking about proportion, null p hat 1 minus p hat 2 equal to 0, alternative p hat 1 minus p hat 2 is equal to 0. Why this one is not being used in our notation of the null and alternative statement? Can someone answer me, class? Instead, we are using null mu1 minus mu2 equal to 0. Alternative, mu1 minus mu2 not equal to 0, for example. Why is this right? Why is this wrong? Class,
Sebab yang tu sampel.
almost correct. You are giving the correct hint, but I'm looking for the right sentence given by you. Go back to the big topic of chapter 3. What is the topic of chapter 3? What is the topic of chapter 3? Relate to the topic. Anybody? Anybody?
Conclusion about population using sample.
Yes, yes. Go back to our storyline. The basis of the story is that we want to make a conclusion about our population. Okay, but it will be hard for us to find all the population subject, and we are going to focusing on the subset of our population called as our sample. Now, what we did was we collect our data from our sample, we measure them, and if let's say we are investigating about the mean, okay, about the mean of our sample, then the notation will be we are investigating about the mean. But this mean that we obtain from the sample is the one that we will use to make conclusion of our population mean, which reflect our mu. That's why in this case we are making inference for our population difference in mean. Okay, and we are testing the hypothesis statement based on the population from the population that we are investigating. So we are testing the population statement, and the evidence is from our sample. Remember, the evidence, these are the evidence obtained from our sample. So that's why from this evidence, we go back to our conclusion for our population mean. If you are talking about the mean, then it will be population mean. If you are talking about proportion, then it will be population proportion. That's why we are testing this statement reflecting the population parameter. This is population parameter for mean. And the evidence to make conclusion are based on the sample. So that's why all the hypothesis statement reflect the parameter of our population, mean or proportion. Okay, so let's continue the last question before we stop. Okay, so from this n and x, we can find our p hat, our Q hat. The same goes to skin cabby, find the P hat and Q hat. But remember, for for two population, okay, for two population, where is the, for the two population, P1 hat, P2 hat, P1 hat, Q hat. Okay, from the for the two population, this one I would like to highlight. So please remember, some of the student who don't really understand, they will make a mistake for sure. Okay, please remember you have, for two population proportion, there will be three things that you have to find. First is the P1 hat, the proportion from the first population or from the first sample. And the second is the proportion coming from the second sample. And the third one is the overall proportion taking into account both sample 1 and sample 2. So you have to remember you have three things to find. That's why in the Excel sheet over here, okay, you are finding the first is the P hat, P hat for population 1 and population 2, Q hat for population 1 and population 2, and the P hat overall, as well as the Q hat overall, because it will be used in your calculation. Not here. You can refer to your book. So you will need that in your calculation. Now, from this particular information, since the difference between the two proportion is not given into any single value, so in this case, the hypothesize, not the mean different, the proportion different. Please make sure you correct them. Proportion difference. Okay. Okay, for the proportion difference. Okay, for the proportion difference is 0. Means that P1 minus P2 is equal to 0. Okay, so P1 minus P2 is equal to 0. This one, this part, P1 minus P2 is equal to 0. Now, let us go back to Excel. Now, the alpha is 0.01 because 1%. The Z test is based on the formula that is given in your textbook. That would be the test statistic or Z test. Okay, it has two names. I think I'll just put Z test or test statistic. Z test or test statistic. The same, they are just the same. So from the calculation, you can you find the test statistic is 1.1478. The p-value, since this is a one-tail test that is located at the right tail, so the test statistic is a positive value, and based on the test statistic, you can find the p-value. So using the test statistic value, you can find the what we call the p-value. Okay, so the p-value is given by 0.1255, and the critical value for one tail. Okay, so you are having this situation. Okay, you have this situation for the second, this one. Okay, saya nak tunjuk apa tadi, saya lupa. What is the thing that I want to say just now? Yeah. Okay, I'm trying to figure out the value that will be the proportion. Okay, so it will be this way. For this one, you have the Z is Z test is Z alpha, Z 0.01, right tail is 2.3263. The Z test is equal to 1.148. Okay, so if you draw, okay, let's say this is your Z alpha and this is your alpha. This give 2.3263, and then the Z test is 1.148. So let me put it in different color. So let's say this is 1 Z test equal to 1.148. So this is the rejection region. And this is the non-rejection region. This in in green color is your rejection region, non-rejection region, sorry. So this is the non-rejection region. All this non-rejection region. So since the Z test falls in the non-rejection region, okay, that's why in the problem, okay, so that's why in this case, okay, the null and alternative statement is over here and the claim is at the alternative. If you are using the traditional method, so 1.148 is less than Z alpha, which is 2.3263, and in this case we make a decision fail to reject null hypothesis. And if you are using your p-value, so we are comparing the alpha with the p-value. Which one is smaller? Okay, in this case, p-value is greater than alpha. So reject the null hypothesis. Or if you go back to the this particular discussion just now, where is the p-value? Okay, in this case, the p-value, let me take the yellow, the orange one. Okay, this the orange, so this one, okay, the whole area here, okay, this whole area here are the p-value. See, the p-value is greater in the region compared to alpha. So that's why in the decision making, we fail to reject null hypothesis. For the confidence interval method, we cannot use because it is a one-tail test. So what is your conclusion? Since the claim is at the alternative, okay, we are trying to find the evidence, okay, evidence of what? To conclude that the proportion of skincare A who will never switch to another skincare is higher than the proportion of skincare B. So in this case, our proportion says that, okay, it shows that there is insufficient evidence to support the claim. Fail to reject null. So when you fail to reject null, means that this statement need to be accepted in simpler way. The claim is at the alternative, but we fail to reject the null, means that this particular statement is the correct statement because our evidence is insufficient to support this one. Okay, that's why there is insufficient evidence to support the claim that the proportion of skincare A is higher than skincare B users at 1% significant level. I think the words switch to another skincare is left out. So you can add. There is insufficient evidence to support the claim that the proportion of skincare A user who will never switch skincare A users who will never switch to another skincare is higher than skincare B users at 1% significant level. So it's too long. Let me higher than. So let me take this one into the next. Oh. Okay, hold on. Okay, so this one, Control X, Control V. Okay, so that will be my conclusion for this particular test. Any question, class? Any question?
No, madam.
Okay, clear. So